Neuroimaging Big Data Analytics using Cloud Computing. Hello, we are undergraduate students from the Department of Computer and Electrical Engineering from the University of Puerto Rico, Maya West Campus.
My name is Fernando Borges.
My name is John M. Hernández.
My name is Arnaldo F. Otero, and our advisor is Dr. Vidya Manian.
Our objectives are to familiarize ourselves with neuroimaging and processing methods, to learn to use Hadoop website services for cloud computing, download the images from a database and process them locally, and finally, to store and process them on clouds.
So what is neuroimaging? Neuroimaging is a non-invasive method for mapping the inner workings of the central nervous system. It allows us to diagnose diseases such as epilepsy and anomalies such as tumors. It can also be integrated into practical applications such as BCI or brain-computer interface, examples of which include neuroprosthetics.
There are two types of neuroimaging techniques. Structural techniques deal with the structure of the brain and the diagnosis of large intracranial disease. Examples of these include CT scans and MRI. Functional techniques show the relationship between neural activity in certain areas and specific mental functions. Examples of these are fMRI, EEG, and PET. Our main focus will be on MRI and EEG. Magnetic resonance imaging, or MRI, creates images of the brain structure utilizing strong magnetic fields in order to excite hydrogen protons in the brain. These protons then release radio waves that we use to create the actual images. Some advantages to this technique include that it poses minimum health risk to the patient and that it allows us to easily contrast between the types of tissue. Some disadvantages are that this technique takes a long time in order to produce results. It is uncomfortable and it cannot be used with certain implants, such as pacemakers.
Electroencephalography, or EEG, is a technique used to monitor brain activity by measuring changes in voltage over a period of time. Results are usually analyzed using a Fourier transform or Fourier analysis, where the frequency components indicate any abnormalities in the brain activity. Some of the pros of EEG include cheaper and simpler hardware compared to MRI and other methods, high temporal resolution, and completely safe or comfortable. Some of the cons or deficits include low spatial resolution, non-specific, that is, it cannot properly identify regions where the data is coming from, and susceptible to noise.
Functional magnetic resonance imaging, or fMRI, is a variation of MRIs that is sensitive to brain activity. It consists of a series of MRIs evaluated over a period of time that measure blood flow in the brain. Blood flow, on the other hand, depends on a particular activity a subject is performing. The benefits or pros of fMRI include good spatial resolution or high location precision when showing results, and provides the specific areas of brain activity. Some of the cons or deficits include poor temporal resolution, which takes a long time to make a reading and is very costly.
These MRI and EEG datasets are called big data, and big data consists of large, voluminous, complex data composed of multiple datasets, like for example, the MRI datasets, emails, videos, or just about anything you can do on the internet. It requires the use of large servers or cloud technology to store and process it, and it is applied to a large amount of fields such as medicine, business, and artificial intelligence. For these EEG and MRI datasets, we shall use the delivery of cloud computing services. They are an alternative to local servers, they alleviate costs, they are utilized over a network, and we shall use Apache Hadoop to process and store this big data externally. We shall pre-process EEG and MRI datasets and later implement them into MATLAB. Afterwards, we shall convert these codes into Java and store these datasets on Hadoop to test them.